Hello, welcome to today's class on my lesson teacher channel. Today's class is a continuation of our previous class on the topic roots of quadratic equation. In our previous class, we achieved the following objective: to solve quadratic equation by factorization, to determine the roots of a quadratic equation using the completing the square method. And today, we are going to achieve the following objectives, which is to derive the quadratic equation whose roots are alpha and beta, and the rest of the objectives. So I urge you to follow up with me as we proceed in this class. In our last class, I gave an assignment, which is to solve by factorization the following: A, B, and also to solve by completing the square method. Now I want you to compare your solution. If you have done the assignment, compare your solution with my own solution. This is the solution to the assignment. 1A is by factorization. You will get the answer x equal to 2 or x equal to minus 5. The B part, you will get x equal to minus 1 or x equal to 5 over 2. Then solving by completing the square method, you will arrive to this point: minus 13 plus root 137 all over 8, or minus 13 minus square root of 137 all over 8. Then in 2b, you will arrive at 7 plus square root 109 all over 6, or 7 minus square root of 109 all over 6. Some people may further the solving, but if you further the solving and you find the square root of 109, it will occur as decimal. So approximation can alter the equation in general. Unless further instructed, you can further the solution. Okay? Now today we are going to look at how to derive quadratic equation whose roots are alpha and beta per se. Okay, now consider the general form of a quadratic equation, which is a x squared plus bx plus c equal to 0. If you divide all through by a, you will have x squared plus b over a x plus c over a equal to 0. Let's call this equation 1. Now, if the roots of the equation I, that's our equation 1, if the roots of I are alpha and beta, what does it mean? It means that x is equal to alpha or x is equal to beta. You can remember when we solve problems either by factorization or by completing the square method, we are going to get two values of x, which are the roots. Now, we assume the roots to be alpha and beta. Let's use the roots alpha and beta to form a quadratic equation. If x is equal to alpha or x equal to beta, we also have that x minus alpha is equal to 0, or x minus beta is equal to 0. If x minus alpha is equal to 0 and x minus beta is equal to 0, the product of these two is also equal to 0. I have that x minus alpha multiplied by x minus beta will still be equal to 0. Now let's expand. Over here we have x times x is x squared. X times minus beta is minus what? Beta x. Minus alpha times x is minus alpha x. Minus alpha times minus beta, the sign will change to plus alpha beta, all equal to 0. Now I have x squared here. Let me write alpha first, minus alpha x minus beta x plus alpha beta equal to 0. I have x squared. You can see x is common to alpha x and beta x. The same with the negative sign. So if I factorize out minus x here, look at the minus. I factorize out minus x. Let me place the x here first. Minus x divide minus alpha x divided by minus x. You will be left with alpha. Minus beta x divided by minus x, you will be, this sign will change to plus. Okay, now x minus, factorize out minus x, you have alpha plus beta. Here you have alpha beta, all equal to 0. Now let me rewrite it again. X squared minus alpha plus beta plus alpha beta equal to 0. We call this equation 2. Now we have used the roots alpha and beta. We don't know their value. We just call one of them alpha. We call the second one beta. We used these two roots to derive a quadratic equation. What is it giving me? X squared minus alpha plus beta, x squared minus alpha plus beta, or in bracket x plus alpha beta equal to 0. This is a quadratic equation formed by the roots alpha and beta. Now, whenever you are given a quadratic equation, you are given a root, you are given the roots of a quadratic equation, and you are asked to derive or to form the quadratic equation with those given roots. You are not meant to go too much process. You use this expression equation of II, substitute the values when you must have determined the sum of the roots, which is alpha plus beta, and also the product of the roots, which is alpha beta. Our main focus here should be the sum of the roots alpha plus beta and the product of the roots alpha beta. Let's take some examples. Let's take some examples over here. I have some examples which say, find a quadratic equation whose roots are A, 3/4 and 1/2, B, -3 and 2, Now solution. A. We remember that the quadratic equation whose roots are alpha and beta is x squared minus alpha plus beta on bracket x plus alpha beta equal to 0. For us to find the sum of roots now, we have alpha plus beta. For A, we have two roots. One of them is alpha, one of them is beta. So 3 over 4 plus 1 over 2. Of course, we can solve this. The LCM is 4. 4 divided 4, 1 times 3, 3. 4 divided by 2 is 2 times 1. We have 5 over 4. What of the alpha beta? Alpha beta is what? 3 over 4 times 1 over 2. 3 times 1, 3. 4 times 2, 8. After you must have gotten the sum of roots and the product of roots. That's all. You go back and put it inside the value. Therefore, the quadratic equation whose roots are 3 over 4 and 1 over 2 is, I have x squared here, I have minus here. From here, I'm now comparing minus, minus. Now alpha plus beta, my value for alpha plus beta is 5 over 4. 5 over 4. I have x, right? Plus, I have plus. My alpha beta, you go and check, your alpha beta is what? 3 over 8 equal to 0. You can as well clear the fraction by multiplying all through by the LCM of the denominators. You can clear the fraction. LCM of 4 and 8 is 8. So to clear the fractions, you multiply all through by the LCM of the denominators. Here you have 8 times x squared is 8 x squared. 5 over 4x times 8, you still have minus there. 4 divided 8 is 2. 2 times 5, 10. 3 over 8 times 8, the 8 is gone. Times 8, 8 we cancel out 8, you have what? 3 remaining, equal to 0. So this is the quadratic equation whose roots are 3 over 4 and 1 over 2. As simple as it is, find the sum of roots, find the product of the roots. You put it in, you have your answer. Okay, let's look at the B part. The B part is minus 3 and 2. We also state that the quadratic equation whose roots are alpha and beta is x squared minus alpha plus beta x plus alpha beta equal to 0. Now get your sum of roots get your sum of roots. Alpha plus beta is equal to, go back, the roots we have is minus 3 and 2. Minus 3 and 2. Minus 3 plus 2. What's the value? I have minus 1. Alpha beta is equal to minus 3 times 2. We have minus 6. Therefore, the quadratic equation whose roots are minus 3 and 2 is, put in the values, you have x squared here, you have minus here. Now, what is your value for alpha plus beta equal? You have minus 1 there, you have x. What is your value for alpha beta? Still have plus. Your alpha beta is minus 6 equal to 0. Now, simplify. You have, which is, if you simplify here, you still have x squared minus times minus 1. You have what? Minus. You have plus, because negative multiplying negative will be positive. X, then plus times minus will give you minus 6, all equal to 0. Simple, right? You don't need to undergo any stress. To obtain any quadratic equation with given roots, find the sum of the roots, find the product of the roots. Substitute into the general form of the quadratic equation obtained by alpha and beta. Your answer is there for you. Further example, which we call example 2, it says find the sum and the products of the roots of each of the following equation. Now you will be given an equation and you will be asked to find the sum and product of roots. As very simple as it is, you have a 2x squared plus 3x minus 1 equal to 0. You have b half x squared minus 3x minus 1 equal to 0. Solution. A. So we are given two quadratic equations. We are asked to find the sum and product of roots of each of them. In this case, we say let the roots be alpha and beta. Let the roots be what? Alpha and beta. We look at number 1. if you compare with the general form of a quadratic equation, you will observe that the coefficient here a squared plus bx plus c equal to 0. The coefficient here a in this case is equal to 2. The coefficient b in this case is equal to 3. And the c in this case is equal to minus 1. What is the formula? Sum of roots alpha plus beta. You still remember? And still remember? Alpha plus beta. If you compare this equation 1 and equation 2, if you compare equation 1 and equation 2, you will have comparing I and II. You will have the coefficient here is still 1 with this. B over A here is equal to minus alpha plus beta. In this case, if we divide through by minus 1, we have what now? Alpha plus beta is equal to minus b over a. If we compare c over a, you can see is equal to alpha beta is equal to c over a. So the sum of roots of a quadratic equation is minus b over a, whereas the product of roots of any given quadratic equation is equal to c over a. This will help us in solving this example. Alpha plus beta is given to us as minus b over a. And if you substitute, minus b is minus 3 all over 2. Alpha beta is equal to c over a. C is minus 1 over 2. So the sum of roots and the product of roots can easily be gotten from here. We have example 2b. We can say let the roots be alpha and beta. Let the root be alpha and beta, then alpha plus beta is equal to, okay, let's bring out what we have in here. In this number b, we have a as 1 over 2. We have our b as minus 3. We have our c as minus 1. Now alpha plus beta, you have minus b over a. I have minus 3 all over a. My a is 1 over 2. Of course, minus multiplying another minus we change to positive, equal to 3 divided by 1 over 2 is equal to 3 times 2 over 1 equal to 6. Alpha beta is equal to c over a. In this case, c is minus 1, a is 1 over 2. My answer will still be in negative. My answer will still be in negative. I have minus 1 divided by 1 over 2, which is equal to minus 1 times 2 over 1 equal to minus 2. Very simple, right? So to get the sum of roots, it is equivalent to the formula minus b over a. To get the product of roots, it's equivalent to c over a. A, b, and c are the coefficients of the general form of a quadratic equation. As we proceed, we are going to look at the measure of roots. Measure of roots. Measure of roots. Of a quadratic equation. Measure of roots of a quadratic equation. The graph of a quadratic equation, the graph of y equal to ax squared plus bx plus c, that's the graph of a quadratic equation, is called parabola. It's called parabola. If you draw any graph of a quadratic equation, it will look like a curve, like this, or it will go this way, the graph is called what? Parabola. Now a question arises: why is the graph curved in your form like this, and also it can curve in any form like this? Something must be wrong. What happens? Or what happened? Something happened. What happened is that in this case, the a, which is the coefficient of x squared, is greater than 0. For example, if you have a quadratic equation, 4x squared plus 3x plus 2 equal to 0. 4x squared, which is the coefficient of x squared, 4, is greater than 0. So the graph will curve in a U form. Now when you have a quadratic equation which is, let me use an example, minus 2x squared plus 3x plus 6. Minus 2x squared plus 3x plus 6. If you look at the coefficient of x squared, which is that our a, in this case, a is less than 0. A is less than 0. That's what happens. Now you have known what makes the graph to either curve in a U form or curve in N form. The graph, which is called the parabola. Measure of the roots proper. You will recall that the solution of the quadratic equation, the solution of the quadratic equation ax squared plus bx plus c equal to 0. Recall that the solution is x equal to minus b plus or minus root D. Do we still remember this formula? What does it look like? Where D is equal to B squared minus 4AC. So the general form of a quadratic equation is minus B plus or minus square root of B squared minus 4AC all over 2A. That is our quadratic formula. You can use it anywhere, anyhow to solve quadratic equation anytime. Now this D represents what we call discriminant. It represents what we call what? Discriminant. And what is the discriminant? The discriminant is B squared minus 4AC. When we have a given quadratic equation and we want to look at the roots, there are three special cases. D is the discriminant. There are three restrictions placed on this D. Just three restrictions. The first restriction, or the first case we can see, is when D is greater than 0. When D is greater than 0, what happens? When D is greater than 0, the roots of any given quadratic equation are real and distinct. They are real numbers, and then distinct. They differ from each other. Real and distinct. Now, what happened to the graph? What happened to the graph? Remember I said the graph can either curve in U form like this, or in N form like this. That's the parabola. Okay, what happened to the graph? In this case, I have it curved like this. I have my y-axis here. I have my x-axis here. When the parabola is curved in a U form, of course we know that A is greater than 0. And also, the real and distinct, the graph will cut the x-axis at two different points. You can see the x-axis. You can see here. You can see here. The graph will cut the x-axis at two different points, telling you that the discriminant D is what? Greater than 0. We also have another case when the graph curves this way. I draw it like this. These are my axis. In this case, the graph also curves the x-axis. We are talking about real and distinct. It curves the x-axis at two different points. Here, A, which is the coefficient of x squared, is less than 0, and B is greater than 0. We still have another case, B. Look at this A. When the roots are real and distinct, you will observe that Another case we are going to see is when D is less than 0. When D is less than 0, what happened? The roots are imaginary. The roots are imaginary. When we say that the roots are imaginary, you cannot obtain the roots on the xy plane. The roots goes into complex. Imaginary. We have complex, it boils into complex 3-dimensional plane, which is the imaginary plane. When we treat complex numbers, we are going to know more about imaginary numbers. So what happened to the parabola? Let's see. In this case, we have the parabola when it's curved like this. Look at the x-axis. Sorry. This is I. When it's curved like this, we have that imaginary. The graph will not cut the x-axis at any point. Look at x-axis. Look at the graph, the curve. Can you see? Here we know that A is greater than 0 and D, the discriminant, is less than 0. Another case we can see it. If this is the x-axis, the graph will curve like this. You can see here we know that A is what? Less than 0, but D is still what? Greater than 0. Whenever D is, now that A is less than 0 and also D is still less than 0. In this case, A is greater than 0, you have a U curve, but yet D is less than 0 because the curve doesn't cut the x-axis at any point. Here, A is still less than 0. When you look at D, the discriminant D, the graph didn't cut the x-axis at any point, telling you that the roots are imaginary. Now the third case, let's look at the third case. The third case C, where D is equal to 0. The first case we treated where D is greater than 0, greater than 0. Second case, less than 0. Now, when D is equal to 0, what happened? What happened? The roots are real and equal. The roots are real and equal. What happened to the graph? What happened to the graph? Look at this one. Look at the graph closely. This is I. We have another one. In this case, as the graph curves like this, first thing you are going to notice that A is what? Greater than 0. Now you look at where the graph curves the x-axis. You can see that the graph curves the x-axis at only a point. Only a point. What does it mean? It means that the roots are real and equal. Equal, only one place. D is equal to 0 in this case. In this case, A, for you to curve any form, we have that A is less than 0, but D is equal to 0. You can see it caught the x-axis at only a point. Only a point. Now let's take some examples, because you'll be given a particular quadratic equation and you will be asked, determine the nature of the roots of the quadratic equation. Without you solving the quadratic equation from beginning to the end, we have done the methods of solving quadratic equation. You don't need to solve the quadratic equation to know how the roots, the nature of the roots, to determine the nature of the roots. Just use the discriminant b squared minus 4ac. If the discriminant is greater than 0, you will know that the roots are real and distinct. If you solve and the discriminant is less than 0, you will know that the roots are imaginary. If they are greater than 0, real and distinct. Then if it's equal to 0, the roots are what? Real and equal. Let's take some examples. Let's take some examples here. Let's take some examples here. The example says, determine the nature of the following. I have the first case, a x squared minus 3x minus 2 equal to 0. I have b x squared minus 6x plus 9 equal to 0. I have c 2x squared minus 2x plus 5 equal to 0. Of course, we can solve the quadratic equation, but the instructions for you to determine the nature of the roots, you don't necessarily need to solve the quadratic equation to get something like maybe 2 and 3. And now you will say, oh, since I've gotten the roots 2 and 3, hence the roots are real and distinct. Fine, you are correct, but save yourself the stress. Solution. Here you have x squared minus 3x minus 2 equal to 0. In this case, what is our a? A, the coefficient of x squared is 1. What is our b? Coefficient of x minus 3. What is our c? Coefficient, the coefficient here we have minus c is equal to minus 2. D, what is our formula for D? D is equal to b squared minus 4ac equal to b squared is minus 3 all square minus 4, a is 1, c is minus 2. Minus 3 all squared is minus 3 times minus 3. Minus times minus is already positive. 3 times 3 is 9. Minus 4 times 1 minus 4 times 1 still minus 4 times minus 2. The sign will change now. You have what? Plus 8. 9 plus 8 is equal to 8 plus 8 is 16. So I have 17. Is 17 greater than 0 or less than 0? Greater than 0. What will be your conclusion? Since since d is greater than 0, look at it. Since d is greater than 0, the roots are what? Real and distinct. This is for A. Let's solve for B. I have x squared minus 6x plus 9 equal to 0. What is my A? A is still 1. My B here is coefficient of x minus 6. My C is 9. B, write the formula, b squared minus 4ac equal to, our b squared is minus 6 all squared minus 6 all squared minus 4. My A is 1. My C is 9. Minus 6 all squared is 36. Minus 4 times 1, 4. 4 times 9, 9 times 2, 18. Times 3, 27. Times 4, 36. 36. So 36 minus 36 equal to 0. D is equal to 0. What is your conclusion? Since D is equal to 0, the roots are real, look at it, real and equal. Okay, now let's look at C. C, we have 2x squared minus 2x plus 5. 2x squared minus 2x plus 5 equal to 0. Equal to 0. Let's bring out what we have. A here is 2. B minus 2. C 5. You write your formula, D is equal to b squared minus 4ac is equal to, you substitute, b is minus 2 all squared minus 4ac, a is 2, c is 5. Minus 2 all squared is 4. I have minus 4 here, so I'll get negative. 4 times 2, 8 times 5. 8 times 5 is 40. So 4 minus 40 is minus 36. I can see minus 36 is definitely less than 0. You conclude, since D is less than 0, what happened to the roots? The roots are imaginary. So the roots are imaginary when D is less than 0. This is exactly the simplest way of knowing the nature of roots without solving the quadratic equation. So when you are asked to determine the nature of these roots, of the roots of a given quadratic equation, just go direct using the discriminant D equal to b squared minus 4ac. Substitute the values of A, B, and C. Whatever you have as the value, you have to check if it's greater than 0, less than 0, or equal to 0. In any of the three cases, you will make your conclusion. So at this point, I strongly believe that you have known so at this point, I strongly believe that you have known how to determine a given quadratic equation with given roots. Whenever you are given a root of a quadratic equation, alpha, beta, or they will be named -2, -3. That is our alpha and beta now. Whenever you are given a root of a quadratic equation, you can go direct by using the obtained expression when the roots are alpha and beta. You substitute. Then when you are asked to find the sum and also find the product of the roots of a given quadratic equation. You are given a particular quadratic equation. The next question is there. The next question someone will ask you is, find the sum of the roots. Someone without the knowledge will end up solving the quadratic equation first before adding the roots, or solving the quadratic equation first before finding the product of the roots. But you, being in this class, we go direct using the formula a plus b, which is the sum of roots, equal to minus b over a, or the product of roots alpha beta equal to c over a. Sum of roots alpha plus beta equal to minus b over a. Product of roots alpha beta equal to c over a. Okay? So that brings us to the end of this class. As you can see, in this objective, we have achieved how to derive quadratic equation whose roots are alpha and beta, and also to determine the measure of roots of quadratic equation. In our next class, we are going to solve numerous problems on roots of quadratic equation. Numerous problems. I urge you not to miss that class because it's going to be an interesting one. All the problems we can come across under this topic will be handled in our next class. So, try and be ready for the next class. For your assignment, you have the following assignments on the screen here. Number 1 says, find the quadratic equation whose roots are a -4 and 5, b 1/2 and 3/5. Then the second one says, determine the nature of the roots of the quadratic equation. A, you have x squared plus 2x plus x equal to 0. B, you have 2 minus 3x minus 2x squared equal to 0. You can see in this case, the coefficient is at the back. So the coefficient of x squared in this case now is -2. So when solving the assignment, take it accordingly. Thank you very much for listening. We have come to the end of this class. The next and the last class on this topic, roots of quadratic equation, will be coming up soon. So kindly subscribe if you are not subscribed. like, reach to us through the comment section, and also share to your friends and loved ones. Thank you for listening.